So another component inside our HVAC system is our pumps, right? Or our pumps. We talked about the pumps before and we said that they provide, so we have our chiller here and we have pump here that provides water. You can see air handling unit. It provides this cold water to pipes, through pipes to our air handling unit and fan coil unit in order to cool down our rooms, right? So the chilled water pump circulates the chilled water from the chiller's evaporator to the building's cooling coils like air handling units or fan coil unit and back to the chiller. And it is responsible for distributing the cooling effect throughout the building. And remember, since we have pumps here, we need to design either an MCC or a motor control center that can be used to control these pumps, or either designing a disconnect switch for each pump. Okay, but usually these are put on one big panel for controlling the motors. These are usually, of course, located near our chiller. Now, an important part which I would like to discuss, when you are designing your own panels, as we will see later, when you are designing the panels, you have to say, hey, I'm gonna design the panels and the transformer based on what loads. So we have our chiller, we have pumps, we have our fan coil unit, we have air handling unit. So how can I design the load? So what we found is that here we have in our air handling unit or a fan coil unit, this is pretty important. You'll find that we have return air, right? Return air. And we can have also a fresh air, right? Return air or a fresh air. The return air and fresh air is used to or provided to our air handling unit or the fan coil unit. And then you can see that we have a cooling coil which contains our water, for example, the cold water from our chiller, and then it will start cooling down and we provide from another grill the cold air, right, as we discussed before. Now this is in what season? In our summer, right? In summer. So in summer we need several components. Number one, we need a chiller. Why? To provide cold water. Number two, we need fan coil unit or air handling unit, like this one here, which contains a fan that takes air and then provide it to our room. And we also need pump, right? We need some pumps that will take cold water and provide it to the rest of the building. Okay, great. This is in what? In summer. What about winter? In winter, I am asking you, do you even need a chiller for winter? Chiller provides cold water, right? We don't need chiller in winter. We need it only in summer. So the chiller doesn't exist in winter. We only need it. However, there is another thing inside the air handling unit or the fan coil unit. You may ask me what exactly exists. There is a heating coil. A heating coil. Really? Yeah, there is a heating coil. So we can have a heating coil that works by electricity using resistors. So this one needs a certain amount of power. So a heater. Or we can have a boiler inside our system. This boiler gives us hot water, which we provide through pipes again, and then we can exchange with air and provide warm air. So it depends again on the design of the mechanical engineer. So let's say we are talking about a heater. Okay, great. And we have what also? We have fans. So we have fans like before, fan coil unit or air handling unit. Fan coil unit or air handling unit. Do you need the pump? You don't need any pump. Why? Because you just use this fan that takes hot air, cold air from the room and using this heater we will provide warm air. So you can see we have two different loads right now, right? So in summer we have fan coil unit or air handling, the fans of the fan coil unit or air handling unit, and we have pumps and chiller as I just explained. And in winter we have the same fans, this too, and we have heater. Okay, great. So let's look at this. So when we size our electrical transformer for our system, we design it based on the summer loads, and we size the main distribution board on winter loads, and not the main distribution board, exactly the sub distribution board. This is a mistake, sub distribution board. Okay, I don't understand what you even mean. Okay, let me show you. So you can see that these are the loads. Okay, great. Now let's see this. So when we look at our system, number one, we have several floors, right? We have several floors. Great. All of these floors, each one contains a distribution board or a distribution panel. You can see distribution board, let's say from here, distribution board, AC, air conditioning, G, ground floor, distribution port, AC, air conditioning, F, first, second, roof, etc. Now all of these panels take from one or several bus bars that are connected to our electrical transformer. So all of this takes its power from transformer. Okay, nice. Now, and we have a distribution port. Each one provides electrical power to our loads, including these fans and heaters inside our system, or any component that we need. So let's look at each floor here. So for example, in the first floor, we need what? Actually, if you look carefully, we need fans and heaters in winter. However, in summer we don't need except fans. So let me explain this. So as you can see here, let's focus on the loads on each floor only. Forget about chillers, pumps, all of this. Let's focus on each floor. So let's look at this floor first. Let's look at this. What components do we have in this floor? Well, we have fans. We have we have heating coil or heater. Great. These are the components in our floor. Now, when do these work? So we have fans that works only in what season? In summer, because we get the cold water from the chiller, and then we use a fan just to provide cold air. However, in winter we use fans and heaters. That is the winter load. So when I'm designing the distribution board for this floor, I have to take the worst case, which one of these, which is the fans and heaters. That's why you can see that the distribution board is designed based on the winter loads that contains both of the fans and heaters. Great. So what about the roof? Okay, let's look at the roof. So all of this contains fans and heater. For the roof, we have chillers and pumps. These are the loads that exist on the roof only, chillers and its pumps. So when do these work? Well, actually these work only in summer. That's why the distribution port of the roof is an exception, which we are gonna design based on summer loads, because in winter a chiller and pumps don't work. So they work only in summer. So when I design this distribution port, in the worst case, I will look for summer. Till now everything is great. So we have summer, we have winter. Now my question for you, when you are selecting the electrical transformer, are you gonna look for winter loads or summer loads? You are gonna design it based on winter or based on summer. Now the answer to this question is pretty simple. I will design based on summer. Now you will ask me, why do you design based on summer? So let's see. So we have in summer, we have chiller bombs. We have fans, fans, fans. This is the summer load. Chiller bombs, fans, fans, and fans. Now in the winter load, we have fans and heaters, fans and heaters, fans and heaters, and we don't have any chillers or pumps. So you will find that the chiller and the bomb is the largest load in the system, pretty much larger than fans and heaters together. That's why when I design my AutoCAD transformer, I design it based on the largest load, which is during summer, when we have chiller and bombs in addition to the fans. This load is much larger than fans and heaters only. Okay, this is the criteria on which we design our electrical system.